This question appeared as a 2-mark question in 2015 CBSE Class 10 Maths board paper, appeared from the topic circles. From a 2-mark question perspective, it's a medium difficulty question. From a point T outside a circle of center O, tangents TP and TQ are drawn to the circle. Prove that OT is a right bisector of the line segment PQ. Let's get started. Let's say point C is the point where OT meets PQ. What we need to prove is OT is a right bisector, which means it has to bisect PQ and it should bisect it at right angles, essentially meaning that we need to prove that OT is a perpendicular bisector of PQ. We're going to be doing it in 2 steps. Step 1, we'll establish one pair of congruence between 2 triangles. Step 2, we'll establish another pair of congruence between a different set of 2 triangles and use these two and the CPCT to establish whatever we have to. Let's start with the first step. In step 1, I'm going to establish congruence between these 2 triangles. I'm going to start with triangle PTO and triangle QTO. I'm going to establish congruence as follows. OP is the radius to a circle, PT is a tangent to the circle. At the point where the tangent meets the circle, the radius and the tangent are at right angles to each other. So angle OPT is equal to 90 degrees. The same can be said for angle OQT. So this is also equal to 90 degrees. In both these triangles PTO and QTO, we've established that each of these triangles has a right angle. OP is equal to OQ because OP and OQ are radii to the circle. So we can establish that OP is equal to OQ is equal to R, which happens to be one side to this right triangle. So we established that these two are right triangles. We've established that one of the perpendicular sides of each of these triangles measures the same. All that is left is to establish that the hypotenuse of both these triangles is the same. OT is a common side to both these triangles. OT happens to be the hypotenuse. So we established that the hypotenuse is also equal. So right angle, one side equal, hypotenuse equal. So by RHS, we can establish that PTO and QTO are congruent triangles. So done that. In corresponding parts of congruent triangles, we're going to establish few things here. If PTO and QTO are congruent triangles, PT and QT are the corresponding parts. So PT is equal to QT. This also comes from this property that we have, that from an external point, the 2 tangents drawn to a circle will be equal. That's what we are saying. The second thing we are going to establish is basically angle PTO is equal to angle QTO. For sake of convenience, let me just give names to these 2 angles. Let them be equal to theta and theta. So we established PT is equal to QT. We have also established that PTO equals QTO. Let's move on to the second pair of congruence that I want to establish. This is between these 2 triangles. I'm going to look at triangle PTC and triangle QTC. In triangle PTC and QTC, we have already established that PT is equal to QT. These 2 sides are equal. Tangents from an external point are equal. So we establish one side is equal. TC is a common side to both these triangles, PTC and QTC. So TC equals TC. We have established that the second side is also equal. So PT, TC, QT, TC. The angle included between them, which is basically PTC and QTC, are the same as PTO and QTO, which is equal to theta. So angle PTC is equal to angle QTC, which is equal to theta. So 2 sides and the included angle are equal. So by SAS, we can establish that PTC and QTC are congruent triangles. We'll run through the same CPCT in this triangle. CPCT in this triangle, we already know 2 sides are equal, this angle is equal. I'm going to look at the third side. The third side is basically PC in one triangle and QC in the second triangle. So PC is equal to QC. If PC is equal to QC and PQ is a line segment we are talking about, then C has to be the midpoint of PQ. C is the midpoint of PQ. Then basically OT bisects PQ. We've established the bisecting part. The second part of CPCT in this triangle that I'm going to establish is angle PCT is equal to angle QCT. Let's say both these angles are equal to alpha each. So these 2 angles are equal, but PCT plus QCT is angle in a straight line. PCQ is equal to 180 degrees. So if I call this angle as alpha, this as an alpha, 2 alpha is equal to 180 degrees, which means that alpha is equal to 90 degrees, which means this angle is a right angle. So we established that C is a midpoint. We've established that PCT is right angle, which means that OT is a perpendicular bisector of PQ. Quickly summarize it. We're going to be doing it in 2 steps. Let C be the point where OT meets PQ. We're going to establish congruence between 2 pairs of triangles. The first pair of triangle is triangle PTO and QTO. The methodology we have adopted is we are using RHS. We're going to establish that two angles are right angles, which are basically angle OPT and angle OQT. Both of these are 90 degrees. Tangent and radii are perpendicular at the place where the tangent meets a circle. OP and OQ are radii and TO is a common hypotenuse. So right angle, hypotenuse and side. By that we've established that these two triangles are congruent triangles. Let's move on to corresponding parts of congruent triangles. We're going to establish two things. One, these two angles are equal in triangle OPT and OQT. And two sides PT and QT are equal. So establish these two right now. Now we're going to establish the second pair of congruent triangles between PTC and QTC. In PTC and QTC, we have PT and QT, two sides of each of these triangles. One side of each of these triangles is the same. The angle PTC and QTC are same. And TC is a common side. So by SAS, we can establish that these two triangles are congruent triangles. Establish that these two triangles are congruent triangles. By corresponding parts of congruent triangles, we can say two things. One, PC is equal to QC, which means that C is the midpoint of PQ. The second we can establish is angle PCT is equal to angle QCT. PCT plus QCT is equal to PCQ, which is equal to 180 degrees, which means each of these angles, PCT or QCT, is equal to 90 degrees. So you can prove that this is equal to 90 degrees, which essentially boils down to the fact that if C is the midpoint and angle PCT is equal to 90 degrees, OT is a right bisector of PQ. Before you leave, do two things. One, sign up at online.maxtute.com. All it takes is 5 minutes and 3 steps to get started with your CBSE online maths coaching. And do not forget to subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.